Alright, hey guys. My name is Nico Ortiz Zarate, and this is my 15112 term project for the fall of 2019. So the project is called Project Athena. It's basically a solar system simulator. So the main idea being to take a look at how different kinds of solar systems would be like, with an emphasis on the conditions for human life, basically. So we're gonna go ahead and play the simulation. Um, there's a little tutorial at the beginning, but since I'm gonna walk through it myself, I'm gonna skip this. So here you're on the main page, and you see this menu bar to the left where you can choose from stars and planets. So the first thing you would do in a solar system is choose a host star. So you would go ahead and click on stars. You have three to choose from: red dwarfs, main sequence, and supergiant stars. For this demonstration, I'm just gonna choose a main sequence star like our own sun, and you can go ahead and place it. Once it's selected, you can place it anywhere on the screen. So I'm just gonna place it right here in the middle, and you're gonna input some values. I know these off the top of my head, but if you aren't really sure what to put, I'll show you in 1 second. There is a reference sheet associated with each one of these that can be toggled on with R, and it goes ahead and tells you some recommended values for that initial input that can be toggled on and off with R. So once you go ahead and place a star, you can go ahead and place planets and such. I'm going to place an Earth-like planet, which would be a terrestrial planet. But first, you would probably want to take a look at what is called the habitable zones of this solar system. So that can be toggled on with Z. Basically, a habitable zone is defined to be the range of orbits in which liquid water can exist, which is one of the key ingredients for life. So based off some of the input that you put in, the program goes ahead and calculates what these zones are, where red would be too hot for liquid water, green is just right for liquid water, and blue would be too cold for liquid water. So the Earth happens to be around 1 astronomical unit away, which is defined to be the distance between the Earth and the Sun, which with this scale in the top left corner tells us is around here. So we're gonna go ahead and input the values, which again can be found on the reference sheet, but I know these off the top of my head. So orbiting around 30,000 meters a second, and an albedo value. If there's terminology in the simulation that you're not familiar with, albedo value might not be a very intuitive thing to know. So I've included some of this terminology in the help page. So we're just gonna go ahead and input that, and comes to life. We have Earth, an Earth-like planet orbiting around a sun-like star. You can see if you pause the app and you click on an object in the system, it goes ahead and tells you some information of what you clicked on. So it's a planet, it tells you its mass, its velocity, its temperature. If it's a planet, it'll tell you what kind of atmosphere it has. So Earth has a rich atmosphere, and it goes ahead and calculates its habitability for human life, which is based off several factors, including distance and position in the habitable zone, type of atmosphere, its mass, its radius. It goes ahead and gives you a number between 0 and 1. So here we have Earth is about a 0.77 habitability planet, which is actually in line with several theories that say Earth might not be the most habitable of planets for humans. But you can go ahead and play around with this simulation and try and create your own system that might be better suited for human life. So that's about it. Thank you. Hope you enjoy.